let me first digress one slide on librfid before getting to the main librfid firmware, which is where I suppose most of the future development is going to happen. So the librfid project predates OpenPCD by quite some time. As I said, I originally wrote it for the OpenMRTD project, which is free software for reading biometric passports. And it supported the OmniKey readers, and now also the adding support for the main dump reader firmware was extremely easy because of the existing support for other readers based on the same reader ASIC. The librfid project has a different homepage. It's even though it's used by OpenPCD, it's a separate project. So yeah. Anyway, where is the main librfid firmware? So it basically then the next step after having main dump reader firmware in combination with librfid on the host PC. The next logical step was to port librfid to run inside the firmware environment that we have in the device. So librfid has been sort of, all the POSIX dependencies that it had to run on a Linux-based host system have been removed, and all the external accesses have been encapsulated. And then you can use a cross-compiler to cross-compile librfid for ARM7. And then you can link that library into the device firmware, and that's basically what we call main librfid. And this basically provides you with the full high-level API of librfid that traditionally people only were able to use on the host PC inside the firmware. So you can, if you've written an application that uses the librfid API on the host PC, you can just cross-compile librfid for the ARM7, link it into the OpenPCD firmware, and then you can run your application inside there. And that works very well. I mean, I was surprised how good it actually works. So the main problem, or problem in quotes, currently is that we have either the totally intelligent device or the too intelligent device or the totally dumb device. Because the main librfid currently doesn't offer USB access. So basically, you can only run your application fully inside the device, or you can run fully on the host, but you cannot have like the stack in the reader and still accessing it from the host. That's one of the to-do items that are still left open. And if you want to venture into that, feel free. We will do it whenever we find the time. I can't give a precise estimate on it. So I'm already drafting or designing a USB protocol specification for the main librfid firmware to sort of take that further. Another thing that I would be interested in doing is emulate USB CCID, so basically emulate a contact-based chip card reader, because that gives you way more software compatibility, so you can run it, for example, using existing OpenCT CCID drivers, or you can use it with OpenPGP, because with GPG, which implements OpenPGP, you can use GPG, which supports CCID-based, contact-based chip card readers. And if we emulate a USB CCID profile, then that could be used without any software modifications. Also, sometimes people think of other operating systems, which I personally find always strange, but then there are people who use Windows and the like. By the way, librfid and that the whole code base, it has not been written specifically for Linux. It just uses basically libUSB, which is now available on macOS, Solaris, Windows, FreeBSD, and Linux at least. So the host software part should actually be very easy to port to different operating systems. And we would certainly be very happy to merge changes if somebody was doing that. But I personally, and I don't think Milos either, have an interest to provide Windows port or something like that. Another thing that I would like to look into is emulate the ACG serial protocol on the debug port that the OpenPCD has. That again gives you way more interoperability, because currently there's no software or hardware, no software API nor hardware protocol that sort of abstracts an RFID reader, even in the 13.56 MHz world, from the application. So whenever you write an application, you write specifically for a certain reader. And so software such as RFIdiot, which is RFID IO toolkit, by the way, doesn't have anything to do with an idiot. And RFDump could be used because they support the ACG readers, which have a specific serial protocol, and if we emulate that protocol, then it could also work with the OpenPCD. So it's just a matter of re-implementing that serial protocol. And then another to-do is writing a nice front-end for the RX and TX, sampling the bit banging for SSC that Milos has been talking about. Stuff like host software to recover the data and to do host-based analysis of the bit stream and stuff like that. And this would really get us way further in enabling people to do crypto analysis on MyFair Classic, for example. And there's lots of other interesting projects, and volunteers are always wanted. Now I'm going to basically end on OpenPCD at that point. Going to talk a little bit about generics on OpenPIC, and then Milos will again talk about the hardware. And after we're done with that, we will do some demonstration and be available for questions. So OpenPIC is basically the counterpart of OpenPCD, and the terminology, for those who are not that familiar with the ISO standards, is actually taken from ISO 14443, because PCD is the proximity coupling device, which is the reader, and PICC is the proximity integrated circuit card. Yes, there you go. So the idea, and if you look at it from a chronological point, it's also might be interesting to you for you to know that we developed OpenPCD because we had a contract to develop OpenPIC, and in order to develop OpenPIC, we needed a reader that we can fully control, so we had to build one. Always these dependencies. It's not just like apt-get, so. The OpenPIC basically tries to emulate existing RFID cards, and again have something that provides you all the interfaces where you can get to all the signals at any level, where all the hardware schematics are available, where all the device firmware and host software is available under a free software license. And in order to keep because those two projects are so closely related, in order to keep the development effort as little big as possible, I cannot say small, is that we reuse the same microcontroller, so we can use the same USB stack, the SPI driver, we can use lots of the parts of the firmware, and we can also use stuff like the device firmware upgrade and some host tools and whatnot, so basically all that infrastructure has already been in place. However, there are no ASICs available for the transponder or tag side. It's logical, and therefore an analog front end and demodulator had to be built discrete from scratch, and that's where Milos is going to take over at this point.
Okay, next try for the microphone. I will show now an introduction into OpenPICC. And sorry.
But can't you read the screen? Come on.
Well, hackers. Better. Okay. The basic idea was that there are in fact front ends available. They are used for near-field communication, but we haven't found any front end that could emulate all the standards we needed. So there was no use of having such front ends because we want to have full control. So we want to get rid of proprietary stuff we don't understand, like this RC632, and we didn't want to play the same game for OpenPICC by using another proprietary front end. The most important part was for not choosing such a front end was that it already removes capabilities to do strange stuff with the interface. You have less capabilities, you are restricted in bit rates, you are restricted in binary patterns. For example, what we definitely wanted was capabilities like saying, hey, I'm 1000 tags. So this was also a core design feature we needed, and obviously it's hard for a front end, or it's not meant to be used as a front end, so it doesn't provide such capabilities. So it didn't make no sense to use such front ends, and we had to design it from scratch. So as I indicated, it's basically the very same hardware. The approaches are also very same. Again, this time we didn't take the 13.56 carrier clock from the oscillator, but we instead took it from the field, which required some smoothing and filtering. But basically, it's very same. We have the picture, whatever. We basically have the carrier. The carrier is converted to a digital signal, fed into the timer again. The timer can be configured to whatever frequency we want. So we can have a frequency that is synchronous to the carrier signal. We can shift the phase again, so we again have full power. So all the features you know from OpenPCD for sampling and replaying stuff are initially meant to be implemented from PICC, and we just took them over. And there was one core design decision which was definitely hard for us. The question was, obviously all these protocols are designed to be done in silicon. So they are highly optimized to be done with as few as possible transistors and whatever. So it would make sense to use an FPGA to do the hard work, to get the bit pattern, to remove the real-time constraints. But on the other hand, we thought, okay, we want to support, we want to be open to as many as possible contributors. And I think it's very hard for a person that never did VHDL design to create contributions. So this would restrain people to the existing implementations for existing modulation, demodulation schemes, and only very few people will be able to add such a code for new cards. And I think, in my opinion, these groups won't match the people that are interested in security and software, in evaluation of computer security. Usually are good coders but bad hardware designers, and hardware designers usually not interested in security. So I think this would be like a break for this project. So therefore we decided to go to the hard way and do everything in software. So to be able to do this with as inexpensive as possible CPU, we carefully chose the device. And if you have a look at the schematics, you find that we use very heavily the hardware acceleration features that provides not only the timers, there are several timers used. We, for example, use functions that are used for telephony protocols to act like trigger conditions on data. There are reconfigurable timers that make sure that the timing constraints are managed. So you don't have to do a silly synchronous design, but you can do a really intelligent reader design where you don't have to poll constantly, but you set up stuff correctly, and most of the work is meant to be solved in hardware, so you can